Avionics are any electronic systems flown in rockets, including flight computers, guidance and control systems, telemetry systems or payloads, and even cameras.
If it is powered by a power source, it is avionic.
And even if you're not the electrical engineering whiz in your team, you can benefit from understanding avionics.
So, let's light it up with some avionics for First Nations launch.
Avionics are really the unsung heroes of rocketry because the adventure of high-powered launches is really about gathering data, and for that, avionics are essential. If there is space and weight allowance in a rocket, then there is some electronic system or useful sensor that can be used to gather operational data. Miniature altimeters and accelerometers are easily available. You can even design and build your own avionics systems. Simple CPUs and flight computer circuits can create some fairly powerful systems using less than 10 components. Let's just start by talking altimeters. Whenever people refer to avionics, they almost always mean altimeters. We want to know how high our rockets travel. This is not only important for safety, but the data is key to analyzing the flight path. At a minimum, an altimeter is required for every dual-event flight. As a result, there are many rocketry altimeters on the market, so it is probably something you don't need to build from scratch.
There are some altimeter kits you might consider, but for FNL, you will be required to use at least one commercial off-the-shelf COTS altimeter for redundant safety.
And even though we focus on altimeters in this video, just be aware that there are many other avionics systems you might consider or the competition might require. Tracking beacons, telemetry, remote measurement systems, onboard navigation, transponders, GPS or inertial sensors, launchpad sensors, like velocity or liftoff sensors.
For reference, GPS or RF tracking devices are required for all competition rockets.
Avionics, like cameras or various sensors, may be located in different stages or places on the exterior of the rocket, but the primary location will be the avionics bay. Note that EEE guidelines require you to bring all of the electronics instruction manuals to the launch location for reference. The avionics bay for most high-powered rockets is located in the coupler section between the booster and the sustainer.
It has three structural components: the housing, the bulk plates, and the avionics sled.
The coupler tube should have a collar known as a vent band or switch band, making it part of the exposed airframe that allows direct access to the avionics bay from the rocket exterior. Your switches will all be mounted in this collar. And your altimeters use air pressure sensors. They will also require vents known as static pressure ports that equalize the rocket's interior pressure with the exterior atmosphere. In a single deployment rocket, the avionics bay serves as the recovery system bulk plate connection for the sustainer and nose cone. In a dual deploy configuration, the avionics bay coupler is both the connection to the drogue chute and the platform for the main deployment charge and parachute. The main ejection charges will be triggered by the altimeters at no less than 300 feet. Your avionics bay will also hold the batteries that will ignite your ejection charges. The charges will be mounted on the forward bulk plate of the avionics bay to deploy your main recovery system. Avionics bay bulk plates have to be both structural and removable. This is typically done by running two all-thread rods through the bay. The all-threads act as force connectors carrying the recovery harness load through the bay without stressing the bay itself. The bulk plates also need to create good seals to prevent hot gas seepage from the ejection charges both forward and aft. You can see how critical the avionics bay can be structurally and electronically. Inside the avionics bay is an avionics sled that can be inserted and removed as needed for repairs or battery replacement. Sled designs can also be innovative. Here's a 3D printed design called an X-sled. Note the integrated tubes for all the thread rods. The most challenging part of avionics sled design is getting everything to fit just right. Plan your avionics layout. Do not, repeat, do not just throw electronic parts together. You will need to conserve space, be able to diagnose problems, and repair and replace components. Your switches need to line up with access points on the outside of the rocket. For dual deployment, you may be using two redundant altimeters with one as a fail-safe backup. Then you might include a beacon, a camera, and all the batteries needed to power everything. You may need to include circuit boards, wire harnesses, and terminal blocks, and of course, switches to turn power on and off. You will need to operate and know how to troubleshoot all of the avionics. Preparation is everything. Read the manuals and take notes. You can literally save hours of trouble by knowing your avionics inside and out. Learn and practice the powering up sequence. Some altimeters automatically trigger. Simply sliding your rocket segments together may increase or decrease the air pressure and activate the altimeter. And make sure you know how to collect the data. Some altimeters have alphanumeric displays, but others have coded reporting sequences. These are all questions you need to have answered long before they become problems.
Switches are really important. Make sure they are accessible from the outside of your assembled rocket.
Two common switch types are pull pins and key switches. Both are fairly self-explanatory. One is a pin that closes the circuit when it is pulled. The other is a key inserted into a lock that switches on when turned. Do not arm your avionics until you are at the launch pad. If you arm your avionics prior to reaching the launch pad, you may inadvertently trigger the ejection charges once they are connected, causing an unsafe environment in the pit area.
Remember to use fresh batteries or recharge batteries before the launch, and then check the charge. It is a good idea to switch to fresh or new batteries just prior to connecting ejection charges. Your avionics plans may fail due to battery power running out while your team waits for launch clearance.
This is often forgotten with dire results. Usually, each altimeter has a dedicated battery, but too many batteries risk making the rocket too heavy, so you will need to consider your power requirements carefully. This is yet another area where early simulations may help. Do not sacrifice the lower end of the voltage recommendations of your altimeter. Here are a few final tips. Carefully check and recheck your soldering and circuits are intact. Soldering failures are a very common cause of avionics problems. It doesn't mean that your soldering is bad, but rockets get moved and bumped and then shaken violently when launched. It is easy for weakened soldering joints to come loose. The best way to protect your avionics system is by rigidly mounting them and securing all components, wires, and batteries. Avionics are some of your most expensive components, and they are meant to be reused, but pyrotechnics, impacts, and failures can take a toll.
Make sure you carry spare components, test gear, batteries, and tools with you when you are launching avionics systems on rockets.
If it doesn't break, you can still misplace it, and a lot of launch time has been delayed looking for parts or begging to borrow them. Don't try to add extra functionality at the last minute. For instance, teams often try to install cameras at the last minute. Luckily, cameras are getting smaller and lighter, and aerodynamic shrouds are available to shield them. They can be independent of your other avionics, but remember that any change to the exterior of your rocket will alter the stability. So plan everything, including cameras, and stick to the plan. Last, test it before you fly it. This may be the most obvious advice regarding avionics, but also the most disregarded. In the rush to launch, outdoors with winds, crowds, and distractions, it is easy, really easy to make assumptions. Remember that this equipment is about to experience G-forces for the first time. You need to do everything you can to prepare them. Simply put, testing is how you prevent failure and stay safe. The longest part of your pre-flight checklist will probably be avionics.
If your avionics are not operating properly, abort launch.
Avionics take time and experience to understand well, but mostly they just require careful planning and testing to succeed. As always, we will assist you, but our first questions will be about the instruction manuals and your planning. So be professional and be prepared.
The guidelines in this video are provided by EEE Wisconsin Rocketry Association, host of the First Nations Launch Program at Richard Long State Recreation Area. When launching locally, please check with your local TRA prefecture or NAR chapter.